Hello folks, we come to the part 2 video of this exercise 5.4 and we are going to check how we are going to solve these problems by and large, how we have done before, same way by substitution or by product quotient rule we will be doing this. So this is our first problem over here in this part, log cos x, let's call this as y, let y be log cos x, cos e raised to x. So we will make substitutions. First to start with, u let it be e raised to x, then v let it be cos u, and y let it be log v. So we'll take their derivatives. Du with respect to x, we all know it is e raised to x. V is in terms of u, so derivative of v with respect to u is minus sin u, and y is in terms of v, so derivative of y with respect to v is 1 by v. Like that, we are going to cleverly use our chain rule, because y is with respect to v, and because v is with respect to u, and because u is with respect to x, we are trying to put it across and we are going to get the chain rule. Now let's see, we have these values with us. This is 1 by v, this is minus sin u, and this is e raised to x. That's all. That's our answer. But only problem is v and u has to be reverted back. So let's revert back. V for us is cos u, and that is cos e raised to x, and this is minus sin e raised to x, and this is e raised to x. So totally it will become, your answer will become minus e raised to x into, if you want, tan e raised to x. It becomes more simpler that way. Yeah, right, that's about it. So next we are coming to the next exercise. This problem is what I was telling right from the beginning, that we are using it elsewhere, so we are taking the derivatives on both sides. So dy by dx, and here it is d by dx of this entire term, that is e raised to x, e raised to x squared, and so on, e raised to x raised to 5. That means it is going to be the derivative of individual terms, derivative of e raised to x, derivative of e raised to x squared, then and so on. It is going to be the derivative of e raised to x raised to 5. Now this is known to us from the problem number 3. What is it? E raised to x, we know by formula, is e raised to x. Derivative of e raised to x squared is 2 times e raised to x squared, we have learnt in the problem number 3. And this is 3x squared times e raised to x cubed. The next term is going to be 4x cubed times e raised to x raised to 4, and last term is 5x raised to 4 times e raised to x raised to 5. Now how we got this is from problem 3 of this exercise. And finally this is your answer. Why? Because we had those terms ready with us over there, right? Then we are going to the next question, which is root of e raised to root x, function inside a function. So let's, for our convenience, call this as y, and one by one let's make the substitution. Here we'll see the innermost function is root x. So let's start with u as root x. So this becomes e raised to u, that is our next function. Function after that will be root v. Just check. We carefully see, you will come to know. If you have a pencil, you can write and erase, and you will get to know how it is. So du by dx is going to be 1 by 2 root x. V with respect to u is going to be e raised to u. Y with respect to v is going to be, we have learned, v raised to half is 1 by 2, or root x is 1 by 2 root x, we have learned it by the formula n x raised to n minus 1. So it is 1 by 2 root v. Like that, our dy by dx will become, by chain rule, y we know is with respect to v we know is with respect to u we know is with respect to x. That way we will apply the chain rule. So we are getting 1 by 2 root v, e raised to u, and 1 by 2 root x. So it is 1 by 4 root x. Now root v for us, it is root e raised to u, which is root e raised to root x, and e raised to u means e raised to root x. Then, yeah, that's all. Now if you want, we can have these clubbed up, and maybe if you want, you can have that cut. Yeah, because this is root into root that this is happening, so maybe you can have that cut and it will become e raised to root x and root of it by 4 root x. So that way, if you want, you can get it shortened up. Yeah, that's about it, and that's how we are getting the derivative. Now we are going to the next problem, log x. So let's see how we do it. That's again an important problem. Y is equal to log x for our convenience, because it's a function of a function. Though as beginners only we require all this. As we develop speed right away, we are able to get the derivatives. But as beginners, because it will take time, so we will as we get used to, and once we gather speed, we are able to do it in a flash. It becomes really easy. But as beginners, so let's get the substitution. Innermost function is log x, so let u be log x first. So what happens to y? Y becomes log u. This is become u, so log u. Now u is with respect to x, that is 1 by x. Y is with respect to u, so that is 1 by u. Like that, finally we try to get dy by dx, because y is with respect to u and u is with respect to x. Dy by du is 1 by u and du by dx is 1 by x. So it is going to be 1 by u for u, it is going to be 1 by log x. And this is 1 by x. Finally it is coming as 1 by x log x. So dy by dx is 1 by x log x. That's it. That's a derivative that we get. For log x, in the long run, we'll always memorize it and keep it that it is 1 by x log x. That's all about this video. With more problems are coming in the next video. Thank you.